I don't see a difference between those three oil pumps.
Hi, I'm Christian.
And I'm Vera.
And in this episode, you're going to learn everything there is to know about the oil pump of the Land Rover Discovery 3 and 4 TDV6 diesel engine.
Hope you enjoy the video. Take 2.
Before we get into the endless details of the oil pump in this video, we gotta cover the oil filter and the oil cooler assembly. That is important to understand what the task of the oil pump really is. Now here we got one of the oil pumps, and what is important to understand is that this is the input side of the oil pump down here. So this gallery here is connected to the oil pickup tube going all the way down into the sumps. The rotor of the pump then delivers the oil through this port into the engine block right below the oil cooler assembly. This is the input into the oil cooler, and from there it gets routed through a channel to the cool in, going through the cooler assembly, and here is cool out. From this port something really interesting happens. It is pushing open a check valve right here. You can see that there is a check valve in this assembly. This is not commonly known, and this is also not explained in the Land Rover manual. So the oil is first going through the cooler, that's still dirty oil. Then the dirty oil pushes open this check valve and it enters the oil filter housing. The dirty oil is getting through the filter from the outside through to the inside. The inside is then the clean oil. This means if you want to inspect your oil, you can run your magnet through these vines here and collect the dust like Vera did this before. Once the oil filter is full with oil, it does not drain back into the oil sump because that is prevented by this check valve. Only the oil which is above the oil tube, which is this one here, this is where the clean oil goes, down into the oil gallery of the engine. That oil drains back through the gallery, through the bearings of the crankshaft and so on, into the sump, but the oil filter housing itself will stay full. You didn't know that, right?
Of course not.
What everybody needs to know, what is the purpose of this little gizmo on the oil filter? It does not have an opening into the oil filter. So this hole you see here is not a through hole. And this plug plugs up this hole inside the oil filter housing. So when I put the oil filter on here, this goes in here and it plugs this passage. When the filter is installed, the oil is trapped inside the filter housing. And the idea is when you do your oil change that you loosen your filter cap by 2 or 3 turns, and that pulls up this filter and it releases this plug out of this plastic opening down there. And that basically opens a drain passage, which is this one here, for the oil to drain out of your filter housing. Otherwise you would take your filter cap off and all the oil in the filter housing would go into the V of your engine. That would be terrible. It's this passage passing over here, going into a little hole here, and from this point directly down into the sump. So that's my lesson to the oil filter housing. We want to compare these oil pumps, and I want to show you a few different aspects. The original oil pump out of a 2006 Land Rover Discovery 3.
Out of my
This
2006.
would be Vera's
Yeah.
2006. And this is a oil pump out of Fabian's Land Rover Discovery 3. This is his 2009 oil pump. Everybody should see immediately what the difference is.
Even I do that. It's not reinforced.
The reinforcement is missing on
Yeah.
the 2006, and on Fabian's 2009 it's already there. If you want to know what happens if this breaks off, you gotta watch the
Outback
videos from
Discovery.
Outback Discovery. He can give you the full 9 yards.
Well, there's not much I can do about the wind, sorry, but there's my tensioner. It's 100% snapped. And there's the big gaping hole in my oil pump.
This thing breaks off. Yeah, it holds the belt tensioner from the timing belt, And when that is, keeping vibrating over years and years, or the workshop tightened this bolt wrong, or the tensioner is adjusted wrong, so it has too much tension, this whole thing will crack off right here. And that will cause a absolute severe engine damage. Everything is wrecked.
By the way, we changed that oil pump
In
in the first 2 weeks of ownership.
And who thought I'm completely crazy?
I did.
And are you happy that I did this now?
Yes. Now that I know what Outback Discovery has to go through.
Yes. Do you love me for it?
Yes.
Okay, so I replaced this. That was the very first thing. What we did. And Vera thought, what the hell are we taking our new car apart? There you can see the reinforcement.
Yeah.
And here is Fabian's new pump, what he bought. Okay? And you can see this pump also has the reinforcement. We're going to look at this pump in a little bit from now. First, I want to show you now a few differences between these two pumps. What I want to show you is the rotor height. What you see in here is the rotor. And I can measure that rotor height. And the way I do this is I go in with my caliper and I null my calipers. Here I'm measuring down here onto the rotor and I null it. I hit 0. Now I got the 0 reading down to the surface. And now I measure from the top surface all the way down, right here. And this gives me a direct indication of the rotor height. So the rotor on the inside is 13.5 millimeters. That's the 2006. That's the weakest pump you can get. Now take a look at Fabian's 2009. And what he's got is the same 13.5. In between the 2006 and the 2009, the rotor size did not increase. All they did is add the reinforcement. Now what we got here is the pump what Fabian bought. Let's measure the rotor height on this one. And this one got a 15 millimeter rotor in it.
They even have 19 millimeter pumps nowadays, don't they?
Yes. There is a Russian pump, which is a 19 millimeter pump. And now the question is, should you use that pump or not? And most likely the answer is no. We're going to get into that in this video down the road. I sum it up again for you. Vera's 2006,
That's mine.
13.5 millimeter rotor, no reinforcement. Fabian's 2009, 13.5 millimeter thick rotor with reinforcement. Then Fabian's new pump, what he bought is a 15 millimeter rotor plus reinforcement. So this pump has 2 improvements compared to the original one from Vera. The manufacturer he's chosen is FAI, F-A-I. There's the box. It fits the 2.7 and the 3. What is also really nice on that FAI pump, what bugged me a lot on all the other pumps I installed so far. This is Vera's pump. Yeah. And on this pump, it's an original Land Rover pump. You can see that the gasket is still, even after years where it was installed, sticking out. Okay, it's not completely flush. I had aftermarket pumps before where the gasket was simply not sticking out. The groove was too deep. The problem is not the gasket. This is Fabian's pump. And see, when I push this in, this is an aftermarket. It's almost not sticking out. Same problem with this pump. Aftermarket, gasket is not sticking out. This pump is on his service invoices, and it was upgraded at one point.
That was done by his previous owner.
This is an aftermarket pump, but probably a Bearmark or Bearmach.
Yeah. That one is softer, but that one feels more like it's supposed to feel.
Yes, this is the original Land Rover sealant ring from 2006. This is the aftermarket one, and it feels stiffer. And it's flattened out. These pumps develop an oil leak right here if the gasket is not protruding far enough. And that's what I like on the FAI pump. Look how far this gasket sticks out. This is really sweet. This pump has a very soft gasket.
Oh yeah.
Oh yeah, that's very soft. And it sticks out really nice. So from the looks of the gasket, I like this pump.
Yeah.
From the size of the rotor, I like it. We're going to investigate what the power output of this pump does and other features in this video. So you guys stay on. When you're done, you know everything there is to know about these pumps. Now the next test I want to do right here on the bench, which is not a big deal, We start with Vera's pump, original Land Rover. This was 115,000 kilometers in the vehicle installed. That's when we took it out. One basic test you can do is you spy out how close the rotor runs to the backing plate. I got here 0.05 in here right now, and you can see it spies perfectly, 0.05. I can get it in, but it's grabbing already. So if I try now a tenth of a millimeter, because there is nothing in between, I bet you it's already not going in. A tenth of a millimeter is not going in. This is pretty darn good that this is only 0.05 excess here. Okay, now let's check Fabian's aftermarket pump, what we took out. Yeah, it's very tight. I can scoop it in.
Okay.
It's very tight, so it's about the same as the original Land Rover. But 0.05 goes in and 0.1 doesn't. Aftermarket FAI. Feels looser. So I want to say the quality of this pump is not 100% as accurate as the other two because it feels so loose.
Yeah, so loose is not good.
Well, you want to have on an oil pump a very small running clearance. See how much play that has? Because it's pumping oil, and when the oil gets hot, it's like water, and then the pump is not able anymore to develop the full pressure because the oil is pushed out through the side gap, a minute portion of it. And if you now use a Russian pump with the 19 millimeter rotor, which is significantly bigger than the 15, I've seen information on the internet that in almost all cases they could stick in the tenth of a millimeter feeler gauge right there. And this would be a problem. You're putting in a bigger pump, but then you're losing its efficiency because the rotor isn't guided well. First of all, when you open up your pump and you look at your cover, you will see the wear mark here, what indicates how much use you got out of your pump and also what kind of oil contamination you had in your oil. This is an engine which was never damaged. Let me wipe over this.
Oh,
so look, 115,000 kilometer original Land Rover pump. So the pump's made by Ford Motor Company.
Oh.
You can see there is some uneven wear, but very small wear. Can you actually catch it with your fingernail? No, no? So this is basically nothing, okay? And then see how this pump impeller goes in here. And one measurement you want to do inside the pump impeller is this gap. When this is backed up over here, you want to know this gap. See, this is my 0.05 going in here. This is the tenth of a millimeter and it's going in. Okay?
And what it's supposed to be?
Well, it's slipping with a tenth of a millimeter. 0.15 doesn't go in. You check this on various places, but it's going to be even. So we're going to compare this measurement now with Fabian's pump before the engine died. Installed at 155, engine died at 190. Let's look at the wear. Very minimal wear, but more than on Vera's, about the same. 0.05 goes in, 0.1 tight. Check this on a few more spots. So this pump is actually better.
Well,
it's newer.
It's newer.
0.1 doesn't go in. That's how I would expect it. Another measurement you can do is now how much play the rotor has. First of all, let's put...
You can take that out.
And you can see how his pump is worn here a little bit. That's because there was oil contamination from his crankshaft damage. See, you got zero wear.
I got zero.
Yeah, this is because this pump was running in a clean engine. This pump was running for several minutes in a completely, destroyed engine. What we also want to gauge when you buy your new pump is the gap between the rotor and the housing. See here, 0.05 goes in, 0.05 goes in, 0.1 goes in, 0.1 over here goes in. This is 0.2, and it goes in, and it goes in, and about the same tightness. This one is a little looser because of the oil contamination, I would guess. I actually want to know what the new pump is. They
don't use Torx.
They don't use Torx. They put some stupid Phillip heads bolts in. I'm not going to install a pump without knowing what's inside here. Okay, we start with 0.1 because we could get in 0.1 on all the others.
Yeah.
And it feels tighter.
Then
over here.
It's 115,000 kilometers.
Yeah. So I would say this is okay with 0.1. Now we check this gap. 0.1 goes in. 0.15 already doesn't go in. So I would say this pump is, from the starting quality, definitely better than Vera's 115,000 kilometer pump and Fabia's 155,000 installed 190 engine rack pump. This here is the pressure relief valve. It's installed and fixed in pressure and limited to 4 bar. So your pressure in your system, depending on the precision of that valve, can never go over 4 bar. The next step is now that we do a performance test on the pump. You don't even know what this is.
Yeah, kind of.
I'm building an oil pump test rig. This is the back plate the oil pump gets mounted against, and this is my spindle housing. The red box with the oil pressure gauge we're gonna need.
I'm assuming it's that one. It's the only red box here. Yeah, that looks about right. It's raining metal chips. Can you see that? I'm gonna need a sticker for here. That's better now.
So you should be able to recognize this part.
Oh yeah.
What is it?
That's where the oil pump goes onto the crankshaft.
41.2, 41.24. This should fit now into the oil pump.
Yep. You're gonna have to cut that out.
It's that corona what's going on. It's the big moment. If this fits.
Okay. So stop recording until that big moment.
And I mean, even if it's only used for 10 minutes, it's still gotta be built right. Ooh. This is my spindle, and I got the bearings now.
Is spindle really the right word?
Yes, this is my spindle. I got the bearings now pressed in.
Yeah.
Now this goes on here. And this is now my drive. Because I made this a little close. And that can be bolted to the pump. There we go. This is our engine. So we can regulate down the flow. You know, because the engine is like a restriction. And without a restriction, there is no pressure. Everybody knows that, right? Because we're really good in making a mess, right?
Oh yeah, especially with oil.
So this gets bolted to the pump like this. Yeah, there. I gave you a hose. Where did you put it?
Oh.
This white hose?
Yeah, I'll get it. Next to our motor bobby car.
Okay, this hose is our route the oil bag hose. Did you clean that container what I wanted you to clean?
Yes, and we are certainly not going to put that oil back into my car.
This is the container, okay?
Yeah. I have to find something in here. Oh, stop recording.
So this is our test rig base plate. Remember, if this is not clean, that oil goes later on in your car.
No, it won't.
It's too expensive to throw it.
Yeah, you can put it in your car or in Fabian's car.
The does not take such oil.
Then that's collateral damage just.
We gotta mount my test rig to this base plate. Where did you put my little collar? The little collar I gave you.
It's here.
So all I gotta do is bolt this now down. We also need an engine to drive this.
I'll do it.
So I have to
Oh
drill and
my
tap
God.
2 holes here.
We never ever ever gonna be done. Yeah.
How often did I say we're done?
Oh, you said it now for 2 hours.
Fortunately, we're not done.
That in the middle.
Some bolts here.
Oh God. Yes. I find everything.
See if this works now.
We're
No,
really
that's
not
good. See?
good. That's what he actually likes. He likes
Yeah.
machining more than working on cars.
Yes. This is a lock collar. This will do it. So now I need a set screw here.
It's gonna take forever.
This goes on here.
I still don't have any idea what he's doing.
This is our performance test stand, what I built. So I have like a backing plate where I can mount the pump to with precision location, and here's my crankshaft. And here we're gonna hook up a drill. Don't want to have any chips because we're gonna put that oil in Vera's car afterwards.
No, we're not.
We're gonna test the new one first because we're running out of time. This pump doesn't have locator bushings. What the hell? They're not even drilled. See, these have locator bushings right there.
Yeah.
Remember, 5 pumps do not have locator bushings. Maybe Land Rover revised this. This is looking good. And I don't want to tighten it down now too tight because I don't want to compress his new gasket here. The outlet port right here. I made this little rig. Okay. This hole lines up with the outlet hole, okay? This goes on here like this.
Yeah.
There. There's a spider walking over my test rig.
Yeah.
What the hell? We gotta prime the pump. A brand new 5 liters of oil. We got our oil container here a little bit in an angle, so the oil runs into the front corner where the pickup pipe is. Now, when we look at the front of the pump, we should be running in clockwise direction as far as I can.
Ah, slower. Ah!
Ooh.
It seized up.
Ooh.
That didn't sound good.
So I'm gonna have to clamp this down.
That's gonna be so interesting.
So explain our new test setup.
I don't.
Okay, now we gotta close this slowly. We close it to 1 bar. Wow,
What?
it doesn't work. Why does it not work? Oh, you know what? We have that in the wrong direction.
Oh my God.
Oh, it got to go the other way around.
I won't be done. It's gonna take an hour.
No, we just have to unscrew this, make a little bit of a mess, and be done.
So look at the mess we made.
So what we got is a strobe light set to 780 RPM. And in the camera, this is probably looking different. But we see now a standstill of the rotor. So we got now 780 RPM. That's our idle RPM. And in idle, the engine is supposed to develop 1 bar pressure.
Now it's 1 bar.
Now we got a setup where the engine is in idle and it's developing 1 bar pressure approximately. And what we do now is we measure now the flow rate, how long the pump takes under these conditions to pump 5 liters of oil back into the canister. Let me think. Better take the camera off.
Yeah, I was just gonna say, you're gonna sync off camera.
Okay, we got a much better setup. Vera is completely stressed out. It's 9:30 in the evening.
No, it's now 10 o'clock.
It's 10 o'clock
In
already.
the evening.
We got the oil pump test setup done. This is Fabian's new oil pump he bought. And what we do now is we got it with a strobe light here, you saw that, adjusted so we know the drill unit is cranking exactly at idle speed. It's around 700 something, okay? A little lower than in the vehicle, but that's okay. Important is that I get repeatable results. So when I push the drill to full power, it idles at about 750. And at that speed, what the pump is running, that's my test speed. I adjust this precision flow control valve so that I read here exactly 1 bar. My precision flow control valve, I can increase the pressure or I can decrease the pressure. So now I got 1 bar standing still, 770 RPM.
Well, we first have to take the time.
Oh, you're completely right. We got to do the time test.
I mean, we got to do the test
The
first.
time test is going to tell us how much oil this pump delivers at 1 bar.
So we stop at 3 liters or 4 liters.
I'm going to run it all the way to 4 liters, but in the video, we're going to stop it at 3 liters.
Yeah, okay.
You got it now?
Yep.
At 3. 1, 2, 3. That was 10 seconds. We should be able to see it in the video. At 3, yeah? 1, 2, 3. Below 10 seconds.
Yeah, you're right. So he's done singing and everything has to be changed again.
Yeah, this is the high capacity pump. The high capacity pump delivers more oil at a lower RPM. If we set our pressure on this pump to 1 bar and later on we do exactly the same setup on a smaller pump, we're not going to have the 1 bar. So what we're going to do is we're going to set it to 1.5 bar. If we run another pump at the same RPM and we get less pressure, we know the pump is weaker.
A little bit more? No? Yeah, that's good enough.
Okay. And this thing, the precision flow control valve, is not going to be changed. It's going to remain, everything is going to remain exactly like this for doing the other pump. And we only have to test one of these 2 pumps because they both have the 13.5 millimeter rotor.
So we're going to use mine.
Okay, it's only a minor oil spill. 1, 2, 3. What was it?
Exactly the same.
So when we later on compare this setup with another pump, we expect to see simply a lower pressure at the same RPM.
Yes.
Okay.
I'm going to sit here and watch you.
Yeah, you can sit there and let the camera run.
Don't really want to know that.
There's the pickup tube.
Yeah.
And we take the pickup tube out.
Which took forever to get in.
Yeah. Now this pump got to go onto the test rig now.
Oh.
Now it's in. See, this one has dowel pins here. This pump doesn't need to be aligned perfectly like Fabian's was. But we connect the outlet. Think about we would have done that with old oil. I put the pressure gauge back on and the pump is ready to go. So what was the changeover time?
The what?
The changeover time, that's what this is called.
Yeah, 10 minutes. It's 22:08 now. Yeah.
It's exactly the same setup, exactly the same RPM, but a smaller pump. And let's see if the pump self-primes.
Yeah.
Yeah, it does. And it's a little less. It's a little less. We've proven now that the newer pump is delivering more oil with that bigger rotor. And now, just to make it complete, we do our test to see now if this makes a difference. Yeah. 1, 2, 3. It was about the same.
It was the same.
But maybe in the video, when we cut it correctly, maybe we see a difference. This test is now complete using this test rig. And now we set up the next test. This wouldn't be LR time if we're not doing another test. And we're going to compare all 3 pumps. So for the next test setup, it's important that the rotor stays in the center of this hole, okay? So I made this clip, which works like a 3-jaw chuck. And I can put this clip in here, and it locks this rotor right in the center into the housing. And you can see, this way it stays in the center. This is the last of our scientific test. What we're gonna do here, we got basically a oil canister connected to each pump here at this port, except on the new one, I actually connected it to the back side, so I don't have to open this plug. And then I got the internal rotor fixed in the center, here with a spring, here was this plastic piece, and here I inserted my drive detail out of my oil rig test pump. So now I'm gonna fill oil into the 3 pumps, which is ambient temperature oil, it's not hot oil, and I fill it exactly to the same level. So each pump's gonna receive about half a liter of oil. And then we're gonna wait overnight, and we're gonna run a time-lapse camera right here with a watch in the background. This way.
It's 11 at night.
This way, we're gonna give it enough time to sink through, and we're gonna see which pump contains that oil the longest. And we're also gonna see how long it takes to drain the entire oil gallery above from the filter in the engine down into the sump, so that when you start it in the morning, that it takes these magical 2 seconds until the oil pressure builds up. We'll put this in here. And there we go.
Stop.
I put
oil.
a little more in everyone.
No, I mean, if we should put this oil into the new pump.
That's good oil. That's brand new oil.
It already looks... Oh, no.
Oh, shit. We almost got away with a major oil spill. I'm using my clamp to put this little rest there, and this is supporting my oil. Isn't that genius? So here, let's fill this one up.
Oh.
There is no laughing in my videos. So, same level.
Yeah.
And then the last one.
Yeah, it's just... No, there's something wrong because it's flowing. It's going through.
What the hell? I forgot to put a plug in the bag. It's always
we have to put in holes.
Yeah. We have to hold it down.
Yeah, but every hole has to be drilled 3 times.
No, it drills only 2.5 times. Put some thread in.
So that's now the 2nd time it needs to be drilled.
Okay, there we go. We're gonna see it sinking in the time lapse if it's evenly or if one is faster. So the time lapse is gonna do that. Here's the time lapse camera. We got the clock in the back. Time lapse is running.
So we need to leave the light on?
We need to leave the light on. Good point. So it's the next morning, and the camera did not completely record the entire night, but we got some footage, and it's good enough to see how fast they drain the oil through. You can see that even now, after 8 hours, Vera's pump is not completely empty. That is quite impressive, I think. I want to give you a quick conclusion out of all these tests. Basically, we learned that the Ford manufactured pump is a higher quality pump than the aftermarket pumps. but we also learned that the manufacturing quality of the aftermarket pumps is sufficient, and it makes sense to change that pump every so and so often and not run one and the same pump over the entire life of the engine. We saw that the pump is basically wearing out over time, and my recommendation is to change this pump whenever you change your timing belt at the latest. And please, if you have a Land Rover Discovery 3 with a TDV6 engine built before 2008 or 2009, you have to go in and inspect if you have the reinforced pump installed or not. That's my conclusion, right?
Yeah. You also concluded that if you change the oil pump, change the timing belt. Whatever comes first.
Yeah, one goes with the other. Now, changing the oil pump is only a little bit more work than changing your front timing belt. The only problem is that Land Rover recommends to remove the upper sump in order to get the pump out, but that is not necessary. You can get the oil pump replaced even without taking the upper sump out. That's really it for this week's video.
That's all we have to say about that.
That's all. That's all we have to say about that.
We love that movie.
If you watch this video and you have not subscribed to our channel, please check out our other videos, mainly the latest engine repair videos. They should be very entertaining to you, and they should tell you if you are up to buying a Land Rover Discovery 3 or if you rather stick with that Toyota. If you like our videos, please subscribe, and as always, and in any case, if you're already subscribed, do not unsubscribe just because we say something stupid in a video.
See you next Sunday.
Thanks for watching.